Welcome to another edition of Math for No. In this edition, we are looking at this interesting problem. So we have this function fnx, which is n square x into 1 minus x to the power n, where n is a natural number, and this is defined for all x in the interval 0 to 1, both 0 and 1 included. Now, first we are asked to find the limit of fnx as n goes to infinity, and subsequently we will have to check whether limit n goes to infinity integral 0 to 1 fnx dx is equal to integral 0 to 1 limit of n goes to infinity fnx, which we will compute there. So let's first find the limit and subsequently we will check. So observe that fn0 is equal to 0 for all n 1, 2, 3, etc. And also fn1 is equal to 0 for all n. So for the points 0 and 1, the sequence fn0 and fn1 are both identically 0, and hence limit n goes to infinity fn0 is equal to 0, and limit n goes to infinity fn1 is also equal to 0. So now we will assume that x lies between 0 and 1. The ratio fn plus 1x divided by fnx by simple calculation turns out to be 1 plus 1 by n squared into 1 minus x. Now if you take the limit of this ratio, this is equal to 1 minus. And since x is between 0 and 1, so this is also between 0 and 1. So from here we can conclude that this limit is a real number which lies between 0 and 1. Therefore, after some stage, which we denote as capital N, for all small n greater than or equal to capital N, fn plus 1 x divided by fnx has to be less than 1, which means that fn plus 1 x is strictly less than fn. So this sequence fnx is decreasing for 0 less than x less than. And also note that all these fnx's are non-negative. By the very definition that we have, fnx is non-negative. So we have a non-negative sequence which is bounded below by 0 and which is decreasing. So we have a monotone decreasing sequence which is bounded below, and we know that such sequences always has a limit. So we can claim that limit n goes to infinity fnx exists for 0 less than x less than 1. So let's call this fx. Let fx be equal to limit n goes to infinity. So what would be this limit? So we had already noted that fn plus 1x by fnx is 1 plus 1 by n whole square into 1 minus. So fn plus 1x is equal to 1 plus 1 by n whole square into 1 minus x into fn. Now, if we take limit on both sides, we get fx is equal to, this becomes 1, so 1 minus x into fx. So this simplifies to fx into 1 minus 1 minus x is equal to 0. So that is x fx. So we are working in the case that 0 less than x less than 1, we have fx is equal. So we have already seen that the limit when x is equal to 0 and x is equal to 1 is 0, and now we have shown that for any x between 0 and 1, the limit is again 0. So the limit n goes to infinity fnx is equal to 0 for all x 0 less than or equal to x. So the limit function, so fx is identically 0 on the closed interval 0 to 1. So the right hand side of this second equation is nothing but an integral of 0. So the right hand side is very easy it is. So let's look at the left hand. Now for the left hand side, we have to integrate 0 to 1 n square x into 1 minus x to the power n dx. N square being constant, we can take this out. Well, this can be done using elementary methods, but we also note that this quantity can be written as, and this gives us the beta function, n square beta 2 comma n plus 1. So this integral is the beta integral with parameters 2 and n plus 1. Now the beta integral has an easy way of computation using the gamma function. So this is, so if you are looking at beta mn, so beta mn is gamma m into gamma n divided by gamma m plus n. And since n is an integer, it is well known that for any integer k, gamma k is k minus 1 factor. So these are very well known results that we can utilize. So utilizing this becomes 1 into n factorial divided by n plus 2 factorial using this result. So this gives n squared into n plus 1 into n plus 2. Therefore, limit n goes to infinity, integral 0 to 1 fn x dx is equal to 1. If you take the limit of this turns out to be equal to 1. It's very easy to see, just divide by n square in the numerator and the denominator and you get that. So we have seen that the left hand side of this quantity is 1, whereas the right hand side is equal to 0. So we can conclude limit n goes to infinity, integral 0 to 1 fn x dx is not equal to integral 0 to 1 limit n goes to infinity. In other words, the interchange of the limit and the integral is invalid for this function. So there are results in mathematics that gives us conditions which makes it possible to interchange the limit and the integral. And obviously this sequence of function does not satisfy those conditions. Hence, we cannot interchange the limit and the integral for this sequence of functions. Thank you.